As we continue talking about rigid transformations, let's just look closer at reflections. And reflections, and of course these are some notes that I've come up with, but we will make sure that we cover the 2 pages that's covered by our text. But just in general, rigid transformations. We want to remember rigid transformations preserve the size, the length, the shape, the lines, the angle measurements of a figure. Rigid transformations are congruent figures. They're the same. All of the properties remain the same. Um, and then, of course, the 3 rigid transformations, reflections, translations, and rotations. You start off, and this is actually backwards. This, by the notation, this is my pre-image. This is trapezoid A, B, C, D. And then, of course, this is my new image, or my image, which is A prime, B prime, C prime, D prime. So all of the lines and all the line segments are congruent, and all the angle measurements are congruent. So now looking more into reflections. In a reflection, all points of the pre-image are reflected across a line of reflection to produce the image. So here we have a pre-image, ABC, and our line of reflection here is going to be line EG. And then here my new image is going to be A prime, B prime, C prime. Okay, so just looking at that. And again, triangle ABC maps to triangle A prime, B prime, C prime. Things that we know here, perpendicular, let's just look at characteristics. My line of reflection is perpendicular to these imaginary lines we drew between our corresponding points. And then things that we also know is we know that this line is parallel to this line, which is parallel to this line. Okay. Again, I'll just throw this in here that we know that all of these are perpendicular, which means they intersect at a 90-degree angle. And we do find out that the line of reflection is going to be sort of a bisector. Okay. So the distance from B to the line of reflection is the same as B prime to the line of reflection. Those two are going to be the same. The same thing goes for here. The distance from A to my line of reflection is the same as the distance from A prime to the line of reflection. And then finally, of course, C to my line of reflection is going to be the same as C prime to my line of reflection. So you can say that the line of reflection is a bisector because it's going to cut these imaginary parallel lines that we drew in half. So looking here, I know that B and B prime is perpendicular to EG. So then also I have segment A and A prime, and then I have segment C and C prime. Those are all going to be perpendicular to my line of reflection. So with that, looking here, again, looking at this example, let's see here, line segment B prime is perpendicular to, we're going to just say it's going to be perpendicular to line, well, it could be perpendicular to line EL, and the different combinations. It could be EJ, it could be EC, it could be EG, any 2 points on that line. I mean, it could be LJ. So just keep that in mind, that there's a bunch of different possible answers here. Point L is the blank of the line B prime. Point L right here, that would be, you could call that the midpoint. Okay, and by being the midpoint, we know then it is also bisects that segment B prime. LB is blank to L prime B prime. Let's see here, LB is what to LB prime? I think it is congruent, right? It's going to be the same length. And then B prime and A prime are, they do not appear to be the same length, right? You know, B prime and A prime are not the same length, but we do know that they are parallel, right? They are going to be parallel. And that's it, being able to identify the characteristics using reflection. Properties of reflections, of course, they preserve, just like rigid properties, rigid transformations, the lengths and the angle measurements, but the reflection do not preserve the orientation. What they mean here is orientation. J is at the top of this image. J prime is at the top of this image. K is at the bottom of this image. K prime is at the bottom of this image. However, L prime, or L is to the left or closest to my line of reflection. My reflection then, L would be over here if it maintained orientation. L would be over here, but it isn't. It's to the right and closest to my line of reflection. So that's what they mean by orientation. It changes orientation. We talked a little bit on reflection across the axes. They do have mappings for that. And that's simply thinking about it, that the x-coordinate will remain the same if I'm reflecting over the x-axis. The x-coordinate will remain the same, but the y-coordinate will be changed by, the sign will become the opposite. So here, A prime, according to this mapping, the x is going to remain x, and the y is going to just be negative y. So I would have -4, because that's my x, and then I would have negative times 2, which is A prime should be, using the mapping, -4, -2. Now if I come over here and I look at it, A is 1, 2 away from the x-axis. And if I go 1, 2, and then A prime would be -4, -2. So we can do it on the graph and count the information, or sometimes that's not available. We have the ordered pairs. We can just sort of think about what's happening. And again, the only thing that changed here for B and B prime is I went from a +5 to a -5, and then same thing with C. I went from a +1 to a -1. So that is my reflection. So it's, oops, not that, right? B prime is going to be x, which is -1, and then -y, which would be a -5, because y was to +5. And then C prime, which should be a 3 and a -1. And that is using your mapping for reflections over the x-axis. Now, reflections over the y-axis, that is going to be a change in, not the y value this time, but in your x value. So it would become -x, y. So again, it's sort of, it's you can see it. You can see it, understanding like K is 1 away, K prime is 1 away. So being able to identify that. So here, I'm just going to put it over here that it's going to be -x, y is my mapping. So K prime should be a -1, and then the 3. So K prime is actually 1, 3 is my new ordered pair. So that's how you would look at that and do that. So L prime is going to be -1, -2, because again, I changed the sign on my x value. And then M prime is going to be -4, again the opposite, and -2, and then N is going to be the opposite, -2, 3. So there you go, looking at how we're doing that transformation, and then of course we can sort of see what's going on here in our image also. The line of, goodness, y equals -x. That is this most basic negative line. And I will just say here too that we have another transformation that if we reflect over y equals x, and that is my xy maps to, I think yx. We'll check it out. So with that, let's see here. Looking at what's going on, this is my mapping. Things that we can see, well, just looking at our mapping, my x values are going to, my x and y values are going to switch, right? X, y, it'll be yx, and they're also going to change signs. So this is when y equals negative x, and this is the line of reflection right there. So just keep that in mind as we look at this. And looking at my a value, my ordered pair for a is going to be -4, -4, right? -4, -5. The b value is going to be 1, -1, and then the c value, which I'm going to assume this is c prime. Well, we don't know that for sure, right? C value is going to be 1, -5. 1, -5. Now, how do you use this? My mapping, again, is going to be -y, -x. So a prime is going to be -5, -y, and then -4, because that is x. So that would become a prime is equal to 5, 4. Okay, so I come over here, I look, a prime should be 1, 2, 3, 4, 5, 4. This is a prime. So that's my new a location. B prime, that should be -1 and -1, which is going to be B prime is going to be 1, -1. And if I come over here and I look, B prime, it's the same location. So if your image and pre-image points do not change, that just means it's on the line of reflection. So that's B prime. And then here, C prime is going to be -5, and then -1, which is going to be equal to C prime is equal to 5, -1. And this is C prime. So there you go. We labeled the items that were present and was able to work with them. Okay. So that is looking at, reflections and how to use that. Here again, this is imaginary line of y equals -x. If I were to look at y equals x, and I'll just put it on here, y equals x, this is what y equals x looks like. The most basic linear function, y equals x. So definitely, here's my positive slope, right? Slope is 1, rise 1 over 1. Here my slope is negative. That's why we have that decreasing line. So there you go. Let's see, look at this problem. Rectangle, Q prime, R prime, S prime, T prime was created using this rule. Determine the pre-image of the rectangle Q prime, R prime, S prime, T prime. All right, so we are trying to find where everything was at. And I will just say that looking at point, let's see, I'm going to pick Q. Okay, Q prime is going to be -2, 4. And then just going backwards, I'm trying to find the pre-image, so Q, let's see here. Q prime, again, is going to be, again, looking at this, right, it would be -2, right, switching, it would be -4, right, and then, -2, -4. All right, so that's what it is now. So just thinking about, I brought my negatives out here. So I see what my original x value was, my original y value. So Q is going to be -4, 2, which is going to be right there, Q. Looking at T, of course, T is on the line of reflection, so that's not going to change. R prime is going to be 4, 4, and that's going to map to -4, -4, and I'm going to have R is going to be -4, -4, which is going to put me right there. And then I'm going to guess that it's going to be my S value right there. But S prime is 4, 2, which would be -4, -2, and again this is my X, this is my Y, so S is going to be -2, -4, and that's where it puts me. So determine the preimage. I can do it. I can do it that way. Some of you may have looked at it and said, I can draw that. I can just draw it without doing any math, but the math will get me there. Just remembering that. Let's see. What is the rule for the line of reflection? Connect your points, right? Connect your corresponding points. This went from here to here, went from here to here. So it looks like I have a line of reflection right over the y-axis. Look and see what also happened. I could say that I'm reflecting over the y-axis, right? The y-axis. But what happened? What changed? When I went here, I had -5, 4 to a 5, 4. So what actually changed? The x value changed to negative. So what is the rule? Well, I went from xy to something, right? So my m is -5, 4. And then my m prime is, well, 4 remained the same. And then it looks like I just have a -5. So it would be my xy mapped to -xy. That's what actually changed. So, and of course we'll do some more of these, but it's just a matter of sort of imagining or picturing what's going on and making sure we can work through it and talk about it. Let's see here in this example, what is the rule for the reflection? It looks like, if you notice, D and D prime and A prime are on the line of reflection. So we reflected over the x-axis, and we know that the line of reflection for that, if we look back in our notes, xy maps to what changed? The y value changed. This was 3, -2. This is 3, 2. So the y value changed. So the x value remained the same, and the y value changed to the opposite sign. So that is my mapping. Consider at number 5 here, consider the reflections of triangle JKL. Okay. What line of reflection maps K to point K prime at -5, -2? So this is going to be -5, +2, sorry. So we're taking K, -5, 2, and then my K prime is going to be at, sorry, K prime is -5, 2, but my original K, that was 5, 2. So what changed? My xy mapped to -xy. So what line of reflection maps that? So there's my mapping. So I would have reflected over the y-axis. So I reflected over the y-axis. What line of reflection maps L? Okay, from L prime would be -2. So that one's a little bit more tricky. So my xy maps to something, right? So L was negative 3, 2, and it is going to map to negative 2, L prime, negative 2, 3. So what changed? It looks like my xy, looks like the number, my xy values change, right? This is my x and y, this is my x and y. So my x and y's switched. And they also both changed from positive to negative, or negative to positive, however you want to think about it. So that is the mapping rule, and that mapping rule would be it is reflecting over y equals negative x. So that is the line of reflection, y equals negative x, right through here. Okay, and let's see, got 2 more to go. It says point P is located at negative 4, negative 7. P is reflected across the x-axis, and that means that my xy maps to, when I go across the x-axis, I go this way or this way, so my y value would change, and my x value would remain the same because it just goes up and down. So there you go. xy maps to x negative y. So this would become P prime. Which of the quadrant is P prime located in? Well, P prime is going to be negative 4 and then a negative 7, right? So P prime is negative 4, 7, which, thinking about it, negative 4, 7, which is up here, and this should be quadrant number 2. Right? 1, 2, 3, 4. So quad 2 is where P prime will be located. And let's see, this one, I will just say that looking at this, remember the y equals x should be xy maps to yx. So my signs are going to, or my x and y's will switch. Signs will remain the same. And it's saying that we're going to reflect this, and that line that we're going to reflect it over is right here. What are the coordinates of E prime? Here's the thing. We have 5 points on our image. They only care about E, because they want to know what are the coordinates of the pre-image of E prime. They only care about finding E. So look here, E prime is what? It is 6, negative 2. 6, negative 2. And that would be the same thing as yx. So if we switch that, that should become E should be y, which is negative 2x, which is 6. That should be E. If I needed to graph it, look at it graphically, I know that it should make a 90-degree with my line of reflection, so I should be continuing over here somewhere. So if I look at that, that would be, let's see here, negative 2, 1, 2, 2, 4, 6, and there is E. Okay, there you go. That is how we could graph it, identify it graphically, or turn around and do it mathematically. So those are my basic functions, or basic reflections. And here are some of the examples. Now let's see here, vertical line, they talked about it. Reflecting over the horizontal line, they talked about it. Reflecting over y equals x, that basic line. Here they've given you some examples, and I'll have these filled out for us in class. But they're saying, hey, in the line negative 1, in this case, they're saying y is negative 1, so they're just picking this point right here. And they want you to reflect over it. Well, My new image would be, this is on my line of reflection, so I would be here, 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 something like that. And I could graph those points, or identify those points on my chart. So that's what they're talking about there. And the same thing with reflecting over x is -2, that is right here. So just thinking about how far are we away. You know, we are away 1, 2. 1, 2. So I go 1, 2. So S prime should be right there. That should be S prime. We come over here. Should be T prime. Come down here. Should be V prime. R prime. There you go. Reflecting over that line. And let's see, we've done these examples, these types of problems, but I will just say in this check, triangle BCD is coordinates. Here they are. They've identified them over here on the graph. Select the coordinates of the vertices of the image after reflection over x equals 3. Let's see here. X equals 3 is right here. Is right here. Right there. That's x equals 3. Just what would be the coordinates for C if I reflected over that line? Well, I'm 1, 2 away, so I'm going to go 1, 2. C prime should be right there, which is 5, 4. I don't have to do the whole triangle to figure it out. Which one of my answers has C is 5, 4? C prime, sorry. That one. Right there. So yeah, you can, some things can be a little bit easier done, you know, thinking about it, using the graphs that are available to you and doing a little bit of functions. So with that, let's see. Oh goodness, looking at this check, Thomas is designing a sculpture garden for an art museum. There is a sidewalk connecting the center of the museum entrance to the edge of the lawn. Okay, center of the museum entrance to the edge of the lawn. Thomas has set 4 sculptures in a series that he wants to be equidistant from the sidewalk. He plotted positions Q and X on the graph. If pieces Q and R are a pair and X and Y are a pair, well, will pieces R and Y be placed? Equidistant from the sidewalk. So we're going to go over here. We're going to go over here. So this should be Y, and this should be R. So it looks like R is going to be 1, 2, 3, 1. There you go. That's going to be my choices for my new locations. So again, just being able to think about, hey, what's going on? I'm equidistant. I traveled one diagonal here, I traveled one diagonal here. Traveled one diagonal here, I traveled one diagonal here. So there you go, using my graphs. So with that, we're going to go do a little bit more work on reflections and really focus on being able to identify and graph and understand where our points are moving.